All right, so now that you have a visual aid in front of you, what do we possibly remember? What are maybe, we'll go for 5 things that you can correctly identify on this periodic table that helps you to classify matter or perform the function of chemistry. Yes?
I think I know
You don't need, you just tell me.
the alkali metals are on the right.
No.
Those are gases,
Or whatever the thing
Oh,
is.
atomic masses.
Okay. So when you're talking about atomic masses, what is the significance of that?
They're atomic.
I mean, we could say that we're talking about velocities, but unless you can clarify that, what's the significance of velocity?
You use it to do the one chart. I don't remember what it's
Physical science.
No.
You figure out velocity by doing sometimes something.
Yeah, the dot diagram.
Because when you say atomic masses, there's components that make up each individual's atomic mass. What would that possibly be? Okay, in an indirect way, that could be correct if you know what the atomic number is and what it is, and its usefulness, let's put it that way. Again, we're just seeing how much you actually remember, and if this is, oh my gosh, I don't remember any of this, ooh boy. It doesn't mean that, oh my gosh, that's not going to set you up for failure for the class. That's not what we're getting at. So then what would the atomic number tell you? It does tell you which element you're dealing with.
Tells you what row.
Does that have something to do with
I don't remember
electrons?
what it's called.
It can. You're getting closer.
Valence electrons?
Nope, not valence. So when you say electrons, we said it can if it's neutral. So you'd have to know what's the value, what are electrons then? That's how you'd have to answer that. Because what's the significance of an electron?
I know it. I just can't say it. I can't figure out
It's
how
in
to
there
explain it.
Mm-hmm.
Well, give me flashbacks from freshman year.
Okay, well, let's maybe try to point us in the right direction. In other words, pick any element on here. No.
Chlorine.
Gold.
Okay. So you could say that we can figure out what the symbol is, okay? Not really all that important, although for writing equations, yes, okay? So what we would want you to think about is look inside this box, okay? In other words, find number 17. 17 is important for a reason. And yes, it can be when you say electrons. You're not entirely wrong when you say it helps you find electrons. But it can't be valence electrons. What else do you see inside this box?
-1 charge.
Okay, so that would be important. What else?
Number 17.
Okay, so then,
Its mass is 35.4.
okay, so then the reason that that's significant is, okay, these two numbers are correlated because that atomic number tells you something very specific about the element chlorine.
It's the 17th heaviest. With the most.
Well, yes, but that you're not wrong.
Don't you do like an equation? Yeah, don't you do an equation to get to the -1 charge?
You do.
I just don't know how it's set
Yeah,
up.
I don't remember.
It's like a formula.
Well, it is, but we can't have a partial one of these, so we would have to say, we're going to say 35 is over here, so here's your equation. So then 17 is over here, because again, that is telling you something very specific. So here's your equation. Something has to be here.
-1.
No.
Three.
35 minus 17.
How about that? Some, because I'm hearing all of these, I heard someone say it. It's not neurons, because we're not talking about the nervous system. Now, if we said, like, morons, well, then I could say, well, take your pick. But, no, someone said it. Yes, neutrons. Besides neutrons, what else will help you solve for this? Because neutron is a subatomic particle. What are some other subatomic particles that we have discussed in the past? Electrons and protons. So why is that significant with that number? It's not electrons. Neutrons is there. So protons. So every element of chlorine is going to have 17 protons. Now, it can have 17 electrons. But when we write it in this state, okay, it would be 18 electrons. Okay? Because how would we solve for n here using your algebraic skills? So that must mean that neutrons equals, right?
Yeah.
Okay? Oh, are we just agree? I should just throw random things up there and just say, sure, that must be right. Okay? So now we said 5 things. So we did that. You correctly said that. That's in there. That's in there. So I think we probably have met that number 5 threshold. But does this now start to look familiar?
Wait, are electrons and protons like the ones that are normally always match up?
Correct. Except for if it's an ion.
Okay.
Because we know that these have positive charges because they're protons. Okay? Neutrons have no charge. Don't always, I think that's the first common mistake. Oh, it's letter N, that must be a negative charge. No, the N is neutrons. And then what we see is it would also have 17 electrons unless you're talking about this. Okay?
Wait, so is the 17 on the left of those protons?
Right here and here? Yes, that's the atomic number. So that's why when we say find element 47, and then you would be able to tell me what element is that. Yeah, Ag. Or if you say find 10, you might not say find 10. It's going to take you a long time. But if you say find element number 50, it makes it a lot easier.
So then the neutrons, the 18, is that not protons, but
Neutrons.
neutrons?
Yep.
Oh, shoot.
And that's significant because, okay, what happens if we do something like this now? Change that to a 36. We go through the same process, okay? This number cannot be the same.
It'll be 19.
It would be 19. There's a specific reason for that. Well, one has one more neutron, but now this is what we call an isotope or a radioactive form of chlorine, which for some of you who go on to take physics of some sort, you may discuss radioactivity and things like that. Not so much, you can with chemistry, probably nuclear chemistry, but that's something that we would not do at this level. Okay, so one of the things that you learned when you were a freshman is you subtract them to numbers, and that gives you the number of neutrons. I know you've didn't. I know you've done. I'm trying to say did or done. What? And my brain tried to say both of them at the same time. I know that you have did it because it's probably in your file folder. I know, or I could say I probably have a stack of papers that showed that you have done this before. Okay? All right. So, when we're talking about for atomic masses, how about we do, do we have NaOH yesterday or NaCl? We know we had this.
NaOH.
Okay. So,
And we changed it to Cl.
okay, then we change it to sodium chloride. Okay? So, one of the things that we see here, I always say round to the nearest hundredth when we're looking at atomic masses in your answers. Round to the nearest hundredth. So, what that means is the atomic mass for sodium, or element what?
11.
Element 11. What is the atomic mass for sodium?
23.
We can say 23 because it's going to say 22.99999. It's not the only element that does that. Oxygen does the same thing, or element number 8. What is the atomic mass for oxygen?
8. Oh,
16.
It says probably says 15.99999. So we just round those two up. We say 23. This one's 16, and then hydrogen 1.01. And when we add those together, right?
Is it 30?
23 plus 16 plus 1.
Oh wait, no, never mind. That was
Okay? Because this is one of the aspects that you'll be doing: protons, neutrons, electrons, and atomic masses on that first paper that you get, I believe. There's no naming compounds or anything like that. We go further in depth a little later in the semester. Okay? Then one of the things that gets to be a little tricky is if these compounds get to be a little more complex. Like, for instance, we did vinegar or acetic acid. And that's probably how you might write a compound like that. You might say, well, why would you not put these two O's together? Because of the structure. Okay? And we could go further in depth and show you that what you're seeing here is this is the characteristic of an acid. So this is based off of its structure. So that's why you see it like that. No, you don't need to know that, but that would just explain why you don't see CO2 and then H. Okay. So if we add together these atomic masses, this is where it's not that it's tricky, but it's so easy to be going too fast and make a mistake. Okay? The simplest thing you could do is maybe, do you write out each element or do you pick one element at a time? Okay? So then, to me, since we read left to right, we would say carbon, and the atomic mass for one carbon atom is what?
13.
No.
12.
Okay? So each and every element of carbon is 12.01. And how many of them do we have?
3.
Okay? Then the next thing we could do is pick another element.
Hydrogen.
Okay? So then hydrogen has a mass of what?
1.01.
Okay? Now this is where it gets to be kind of tricky. How many hydrogens do we have? No.
6.
I see
Fine.
3, I see 5, but
Oh, but you're only doing this.
not just doing the first one. Because we didn't stop with just this carbon. We saw 1, 2, and 3. So that came from. But how many hydrogens do we have?
Oh, there's six.
There's 6 of them. 3 here, 2 there, and then 1 on the end. That's why we said when you're going too fast or you're not paying attention, it's very easy to make a mistake. Okay? So then we said that there's 6 of those, and we can come back to that at a later time. And the mass of 1 oxygen is what? 16, and we have, okay, so I can handle these 2 maths. Actually, we can probably handle both of them. So 32, 6 times 1 is what? Okay, and then if you had 3 dozen eggs, you'd have how many? Okay, and then carry that over. And then you could add those all together. And I might do it wrong myself.
72.09, right?
Oh, see, I went 6, 6, and 3. That's where I came up with 15. Yep. Instead of doing the 2, I had done the 3. So we got 12, 14, 1, 4. And then, of course, you have what's left over there. That's right. Okay. Because the reason that is significant, we really didn't learn this in physical science. We never really put a label on there. Yes, we could put grams, and you would not be entirely wrong with that as well. But when we start talking about atoms and moles, it gets to be more important where we put a label on there as grams per mole. Okay? The reason we call that a molar mass label is that for every 74.09 grams of acetic acid, you have 1 mole of acetic acid. If you had, what would that be? If you 148 maybe. Just trying to visualize that in my head. If you had 148.18, double that, how many moles would you have? You'd have 2 moles of that, okay? Because one of the things that I think it's hard for students to wrap their heads around is when we talk about moles, it's just a counting unit. Because the example we gave is tied to this, okay? Maybe for you having a social function at a church or a family outing or family reunion, and you're responsible for making egg bakes or scrambled eggs, okay? You're not going to go to the store, oh, I need to get 72 eggs. No one's going to say that, okay? Or I need to get 36 eggs. No one's going to say that. How else might you say that?
3 dozen.
You need 3 dozen, okay? So that 3 and the 3 dozen is a counting unit, just like that of a mole. That's all it is, okay? And if you had 72 eggs, oh, I need 6 dozen. Same thing when you're dealing with that of lengths as well, okay? We're not talking about 80, see, I got to think about that now too. Is it 86? No, 96. This is 96 inches wide, but you wouldn't talk about 96 inches. You'd rather say what in feet? It'd be 8 feet, okay? That's plywood comes in 8 feet, so we're not cutting anything. So when the factory made this, it is 96 inches long or 8 feet. So the 8 is just a counting unit. It just makes it much easier dealing with numbers rather than always using these as this is just a conversion factor for it. Okay, now, do we remember quite a bit of this from physical science, or is it, oh boy.
This right here.
Yes.
A little bit of
I
it,
remember,
yeah.
I remember the other stuff, but this is like.
Okay.
I don't remember doing this. I remember doing like the typewriter.
Okay.
I remember like the last quarter.
So, and one of the things I am looking out in the audience here, a lot of people, who can we pick on?
You can pick it, Thomas.
Okay. So, as we look around, since you were picked, what is everyone else doing but what you're choosing to do? Yeah, so are you doing that? Why not? And that's fine. Maybe you already remember how to do all this. Would you choice? Okay, it's your choice. Okay, so then when we maybe start naming compounds, do we remember doing that?
I think so.
A little bit, yeah.
Okay, so when you throw some of them polyatomic ions, that gets to be maybe just a little more difficult or confusing. So what do we mean by a polyatomic ion? We did one already. It was hydroxide, the OH ion. But what we mean by that is, I don't know if you're going to know this, what do farmers put back into the soil in, I suppose you could say, the spring or the fall for the next growing, probably in the spring? It's fertilizer, but it's high in what element? Starts with an N.
Nitrogen.
Yeah, you're going to put nitrogen back in the soil. So therefore, you're putting some ammonium nitrate. Okay? One of the reasons you do that, nitrates are very soluble in water. Okay? So when it rains, it can be absorbed into the soil because this, again, is so water soluble. So upon doing that, then, let's see here. I don't think I took rolls. I'm going to pause for just a moment. Okay, so the atomic mass for ammonium nitrate, how would we figure that out?
You look at it in your elemental table.
Nitrogen.
Okay,
2 nitrogens.
14 times 2.
okay.
Is that A?
And then hydrogen. 0.1.
Are we done with that nitrogen then, or is there something else we need to do?
Is that an N by the H?
Yes.
This? Yes.
Okay.
Yep. Are we done with this?
Yeah.
Are we done with this?
No.
Okay. We still got to compensate for that yet.
Oh, 0.02.
Okay. So then we took care of our nitrogens. What else do we have?
Hydrogen,
Okay.
Hydrogen.
And oxygen.
which is 1.01 times 4.
Okay. And then your oxygens. Okay. So then we would add those together. Okay, so you're 12. Is that right?
80 point, I got 80.06.
Where did I make a mistake here?
You have to add the 4.
Right off the top.
Oh, yep, I skipped that. All right. Okay, and then when these get to be, again, a little more complex, let's maybe, some of these lighter colors, I'm not sure if they'll show up. Let's do some of this instead. Okay? So, atomic mass of calcium is what?
I know.
40.0.
7, 8.
And how many of them do we have?
2.
Yeah.
Okay?
I have yet to write.
We got 2?
No, just one.
Yeah,
I hear-
Don't you have
You
to?
don't have to distribute anything other than parentheses. No, you only have one.
I think it's 2, because of the number.
The NL. It's 6 NL. Whatever. So it's doubling. Well, there's 6 O's.
We still have not wrapped up. No one's came to total agreement. Is there 1 or 2 of these?
It was 1.
Because
I
you don't
think so.
distribute, you don't distribute the 2 to anything outside
The
of the
2 just goes to
parentheses.
Yeah, the 2 only pertains to what's inside here.
Oh, so just 1.
Just 1. Okay? So then, how many nitrogens do we have?
I can't see.
2.
So then we can just take that from up here. Okay? And then, how many oxygens do we have?
6.
Okay?
6.
So then, 16 times 6.
96.
Okay? So then we've got 10, 1, 1. About that. Grams
Yeah.
per mole. 164.10.
We have to put the 1 0 at the end.
Yes. I would highly recommend you do that because when we start doing different types of mathematical problems like this, you're going to want to have this in here because that's another aspect that you're going to have to sort out in college is what we'll call significant figures. Yes?
Okay, so I don't really understand how the moles work, because if everything is grams per mole, then is like one of it 1 mole?
Yes.
So no matter what it is, it's 1 mole?
Mm-hmm. When you add it up on the periodic table, yes.
Wait, everything is 1 mole?
Mm-hmm.
How does that make sense?
Because each substance is going to have a different number on the periodic table.
So it all changes because it's different, like.
Different elements, different proportions. Right.
Where'd you get the 4008 from?
That is the mass of calcium.
So if you were to ask how many moles would be in that, it'd just be 1?
We're going to start talking about that tomorrow. Mm-hmm. Okay.
Okay.
So, front row, are we on the bus?
Yeah.
Second row, are we on the bus? Third row, are we on the bus?
Yeah.
Would you want us to round to the 100?
Tenth. Or I said 100th, yes. Yep. Okay. So, what I want you to do someone in the splash zone. Who are you pointing at?
Nothing.
Oh, I thought you were pointing at with your pen there. So then now point at someone in the splash zone.
Oh, shucks.
You can even say it yourself.
Oh, me.
He does.
Oh, okay. So, not hydrogen.
Not hydrogen.
So
Okay.
not hydrogen.
Nickel.
So not chlorine.
Okay.
So pick an element off the periodic table.
Nickel.
Copper.
Okay? So what is everything that you can tell me? So you had to have picked copper out, so you had to have seen it on the table.
Yeah.
So what is everything you can tell me about what you see inside that box?
Its atomic mass is 63.546. I think that's what it says on them. It's hard to see.
Okay.
The atomic number is 28.
We can put that over here.
It's 29.
Okay.
It has a +2 and a +1 charge.
Okay, that's true. That will be more important later on this semester.
Okay.
Anything else?
It's like a
It's metal. Metal.
True.
Oh, CU.
Yeah, I see you.
Oh, yeah. That's the symbol is CU.
I see you.
Oh, okay. I don't know what else.
It's not I see you.
No, it's CU.
When are you gonna see me?
You picked a terrible one.
Well, dang it.
All right, we'll just. All right. Okay. So we're gonna change this from 63 to that. What is everything that you can tell me about this element carbon? Don't worry about the +1 and +2. We said that'll come later.
29 protons.
Okay?
Whoa. 60 or no, 35 neutrons. Continue. Is this to subtract it? Oh, it's like the
One more.
Electron is 29.
You weren't that confident when you said that.
29. Electron.
Now, are you sure?
Yeah.
Okay. The reason that we had said, okay, you said this is in your box as well. You're 100% right. It might have those flip-flopped. It's not a fraction. It's just telling you different charges that copper can and would form. Because when you start talking about these, we need to switch the electron number around. But for our practical purpose, we're saying that this is a neutral element right now, which means the number of positive charges has to coincide or cancel out the number of negative charges. So therefore, that's why we got rid of that +1 and +2. Okay? So that is how we would look at that for the element copper.
Wait, how do you know if it's neutral again?
You'd have to be told that, just like you'd have to be told this. Yes?
So would you say the number of electrons in chlorine is 17 as well?
That's correct.
Okay.
Okay? All right. So tomorrow I would presume would be a good idea to, let's see here, we've got, so I need to change that. We've got, is it 12 students in here now?
I got some pretty.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. So second middle shelf, that's where your textbooks are located. Grab one when you come to class because we will be utilizing them tomorrow. We'll catch up to you next time.